this one came out in October, and it's a big, heavy 500-page book about a computer language called Julia. And again, this was actually, I got an email from an editor that I worked with who moved from her editing job at a journal, at a Linux journal, moved to working for this publishing company. And when their market research indicated that there was a gap in the market for a book on this particular computer language, she remembered that I had written an article for her on the language, and she sent me an email and said, "Do you want to write a book now about this?" And I said, "Yes." And so like 2 years later or so, we came out with this book.
Okay. So through a mutual acquaintance, I learned that you started doing some science freelance writing. How did you start down that track?
So after I retired from the Naval Research Laboratory, I'd always enjoyed writing papers and so on. And I continued to do some research and consulting and stuff, but I wanted to write some popular science articles. And I didn't know much about how to get into that field, but I think it started when I was reading through Ars Technica, which is a very good online technology and science magazine, well, purely online magazine. They don't have a print version. And I noticed that they had a note there inviting submissions for articles. So I said, and send us your ideas. So I sent an email to the editor with 3 possibilities of 3 articles I could write. And they picked one. And so I wrote it, and they accepted it, and they paid me, which was a great bonus.
Yes.
They had paid for writing something. It's not, you don't get much money writing freelance articles, but it's nice to get paid for doing something that's enjoyable, that you want to do, which is explaining science technology to the public. And I don't know, I just hit the mark with that article. That they told me that this article turned out to be very popular. They have their metrics for how many people clicked on it and so on. And they said, this does all our metrics. They really worked well, the article. And so I immediately had a good reputation with them. So I published a few more. I kept sending them ideas. And I branched out and started sending queries to other publications. And, you know, I guess 2/3 of them get rejected, but you just keep sending them out. And you find an editor who likes your idea. And basically, there's no secret to it. You simply send out queries to acquisitions editors, and if they want to publish your stuff, that's their job, to read these queries and decide if something fits into their publication. And if it does, they publish it. But it starts out slow because no one knows who you are.
Yes.
I mean, if you have an academic background that qualifies you to write on the subject, that helps. But they don't know if you can actually write, and they don't know if they can work with you. In other words, you have to meet your deadlines. You have to cooperate with the editors and the proofreaders and all of this. And when you're an unknown quantity, they're taking a risk on you because it's an investment of their time and money. But after a while, after you get 5 or 6 articles published, you get a reputation where people know they can work with you, and it becomes easier to get things accepted. So it's like anything else. You just start by starting.
Yes.
If it's something, but you have to really enjoy writing, because if you calculate your hourly wage for writing freelance articles like this that take a lot of time to research.
Yes.
Right? It's like something not too much better than minimum wage, really. But it's something you can do sitting in your house or sitting outside or sitting in Starbucks, and it's just a lot of fun. If you enjoy explaining things, if you enjoy learning about things, interviewing people, talking to different people, drawing diagrams, and just giving your opinions about science and explaining complicated ideas to the public, then the payment is kind of a bonus. You just can't quite live on it.
Right. Right.
But it can lead to other things. So if that by itself is not a good way to make a living, however, the reputational aspect of it leads to other opportunities. So I've written 4 books, and the last 2 that I mostly wrote during the pandemic when people were sitting at home, they were basically, people came to me and asked me to write their books, and it was because of articles I've written. Right? So eventually you get known as someone who can write about these subjects in a way that is understandable.
Yes.
And can also meet deadlines and keep the schedules and cooperate with editors, which is just as important as the other stuff.
Okay. Very good. Yeah, there's a whole science. I mean, there's the science and there's the whole science writing world. It's a world all in itself. Yeah. Okay. So you mentioned your books. Talk about the 2 books. Well, actually, it sounds like 4, but I saw on Amazon Einstein's Tutor and Practical Julia.
Okay, thank you for the opportunity to promote my books.
No problem.
So this one came out in October, and it's a big, heavy 500-page book about a computer language called Julia. And again, this was actually, I got an email from an editor that I worked with who moved from her editing job at a journal, at a Linux journal, moved to working for this publishing company. And when their market research indicated that there was a gap in the market for a book on this particular computer language, she remembered that I had written an article for her on the language, and she sent me an email and said, "Do you want to write a book now about this?" And I said, "Yes." And so like 2 years later or so, we came out with this book. Julia is a language it's fairly new. It had its first public release in 2012. And it was intended to be a language for scientists to do scientific calculations, simulations, and data analysis and things like that. But it is, in fact, a general purpose language that you can do anything with. The motivation for it was, I don't know how boring this explanation will get, but you're familiar with languages like Python, perhaps? Okay. And other languages like Fortran. Yep. So the classical language for scientific computation is Fortran.
Formula translation.
Yeah. This is actually the first high-level language that was invented. Before that, people published or wrote in machine code or assembly language, which is very time-consuming to write it. It means writing individual instructions for that particular processor. It's very far from the problem. So when more scientists wanted to do calculations to predict the weather, to predict the path of missiles, things like that, it's always military. They wanted a language that was closer to the mathematical formulas that they used. They didn't want to write a lot of individual instructions to multiply 2 numbers because this is too time-consuming. So Fortran was invented, and as you just said, it stands for Formula Translator. In Fortran, you can write code that looks like your equations, right? And you can have data structures such as arrays, or vectors, or matrices that look like the data structures that physicists think about. And you can have if statements and loops and everything all the basic equipment that you need to describe a computation. So it was a revolution. Now physicists who were not computer scientists could write programs and predict the weather or the circulation of the ocean. And it was very fast, very efficient. It's still probably the most efficient language for doing numerical computation. But it's, in other ways, it's kind of primitive. Modern Fortran actually is very nice. It has very expressive constructs for operating with arrays and things like that. But it lacks a lot of the features that in the 50 or 70 years since it was invented that people expect to be part of a convenient computer language. It doesn't have all those things. It's still very clumsy when it comes to input and output in writing reports. It can calculate, but when you want it to write the results into a file, that part of the programming is very clumsy.
Okay.
Because it wasn't designed to make that easy. But it's still beautiful, nice language. So there was another generation of languages. There was Lisp, which is also very old, and COBOL for business, which is also quite old.
Mm-hmm.
Slightly more recent, but also an old generation is C, which is like a slightly higher level version of some language. So a lot of science gets done in C or C++ now. But it's still verbose to programming. So in the 1980s, the language Python was invented, which is much more pleasant and convenient to programming. We have something that computer people talk about called, what does the hello world program look like? What do you have to write to get the program to say hello world?
Mm-hmm.
Right? So in Fortran, it takes a few lines. You have to have some input-output statements. It's not just one line, it's several lines. In C++, it's a whole page to get it to say hello world. In C, it's maybe 10 lines. I don't know, you have to import the standard I.O. package, the header. I haven't programmed C in a long time. But in Python, you just type hello world inside quotes, and it will say hello world. Or you can say print hello. If you want to say print, you can say that.
Okay.
So it's one line. The hello world program in Python is one line. You don't have to import anything. You don't have to define the data type of any variable. It's one line. So this is what we expect for a convenient, friendly, expressive computer language to be like, and Python is like that. It has other things that I don't like, but it is expressive and convenient and pleasant to work in. And it's so nice to work in that scientists try to use it, and you can actually use it to do a lot of science.
Mm-hmm.
It's very useful for analyzing data, say from experiments or from simulations. I used to do simulations at the lab, NRL. I used to do a lot of simulations in Fortran, but then I wrote Python programs to analyze the data from the simulations, because it was much easier to massage the data and make plots and visualizations using a higher level language. Right? But Python has a couple of problems, however. It's inherently slow. This convenience, because it's not a criticism, it was invented in the 80s, right? And compiler technology was not what we have today. Right? Compilers in those days were not as advanced as they are now. So a loop in Python is very slow. If you just loop over an array to say if you want to add one to every element of a vector, it'll be an array. So you loop over the array, and that is inherently very, very slow, which usually doesn't matter unless you're trying to do a high-level simulation, or a high-level computation, or something like a physics simulation, and then it's just too slow. So what scientists started doing who wanted to use Python for the data analysis, high-level parts of the program, but also wanted to do simulations, was it started writing in two languages.
Okay.
A fast language to do the simulation, and then Python to do the convenient data analysis and the interface with other programs and things that it's good at.
Okay.
Or there are different versions of Python that sort of incorporate C into them, so you can have C routines that look like they're part of your Python program.
Yes.
But they're not really. So you still have to be an expert in two languages.
Yes.
You can import a library called NumPy, which had fast array operations, but that itself is written in Fortran and C. So unless you did what was built in, you still have to know how to extend your computation using other faster languages. So this became known as the two-language problem. In order to be a scientist using Python, if you wanted to do fast simulations, you had to maintain your code base in two languages. You had you had to have experts on your team in Fortran or C and experts in Python, and you had to coordinate those two parts of your calculation. So these guys who invented Julia were four computer scientists from MIT. Said, we have compilers are a lot more sophisticated now. We're at the point where we should be able to write in language that is as high level, as easy to use as Python is, but has no compromise in speed, runs like Fortran. It should just be one language. The compiler should be able to take your high-level code and compile it all the way down to machine code, fast, native machine code for the processor that you're using. And they actually succeeded in making a language that does that. And that language is called Julia, for no reason, by the way. The name comes from nowhere, according to them. They just made up the name.
Okay, Julia
It's
for the
nobody's
sake of
girlfriend
Julia.
or anything.
Right. Okay. So, thank you for that explanation. So, the other book I saw on Amazon was Einstein's Tutor. Thank you for watching this discussion. It will be continued in subsequent installments. Please leave any questions or comments in the comments section below. And finally, please like, share, and subscribe, especially if you are new.